Okay, we're going to stick with this data for just a second. I wanted to show about adding data to a graph. So let's say you're going to graph this much. I'm going to insert the graph, and that's predicted, so I'll make it a smooth line. Okay, it stops short. It stops too short. I wanted to see more of the line. There's an easy way to correct that. I've already mentioned in the previous video, I mentioned if you get the wrong columns, best thing to do is just start over. If you get the wrong rows, you can do this. These little squares at the bottom let you select how many rows of data, and if I can get the cursor the way I want it, there we go. More rows of data or fewer rows of data. If I don't want 0, 0, I grab the square at the top and pull it down. This is true of any graph. You can do that. Okay, let's move on. Now I brought up the graph of two sets of data simultaneous just by selecting all three columns and doing the graph. I wanted to point this out right down here. It's called the legend. You can move it around. You can format it just like everything else in Excel. I'm going to right click. I'm going to format the legend. One trick with the legend you might like is you don't want to see these grid lines going through it. So you can go to fill and put in a color. Instead of automatic, you can select the color and say white. So you have a white background. You'll notice you can change the colors of these graphs like crazy too. And I'll close down the formatting tool. And now make a nice big font so you can see it. There. So just like you can format other text boxes, you can format this. And this one might be valuable to format because then you don't have grid lines going through your text. And of course, right click to change the look of the data to choose markers only or lines only. A legend is an important chart element you want whenever you have more than one column of data. I also told you I was going to show you how to move a chart to a new worksheet. You can put a chart on its own worksheet. I can right click it. There we go. It says move chart, and you get a dialog box up, and I'll move it back so you can see it. New sheet. The default name is chart 1. You can name it whatever you want. And you get a new sheet with a new chart. You put everything where you want it. The legend is too far out of bounds, so you can move the legend. You can change the size of the legend. There we go. You can change the appearance of the legend. You can put it more in this corner. You can put it wherever it's convenient. A legend you can put wherever it's convenient. There. You can put a box around it, things like that. Okay, moving the whole chart. Wanted to show that too. Now we're going to move on to a different kind of chart, and that is changing. Okay, so this is a plot. It's experimental data. It's curvy. It is not a straight line. Just like the previous one was also curvy. It wasn't a straight line. But there's some things you can do to change the appearance of the graph so it looks like a straight line. And you want to do that because that tells you what kind of equation you would have going through this data. So select the axis right here, right click on it, and it says Format Axes. And right down here, there's something called logarithmic scale. This is a semi-log y. In other words, the y-axis is on a logarithmic scale. And wow, it looks like a straight line now. You'll notice the scale goes from 1/10 to 1. So between here and here, it changes by 9/10. Between here and here, the same distance on paper, it changes by a factor by 9. You add 9 to it. It changes by a multiplier of 10x. From here to here, it changes by 10. So this is very useful to help us understand what the equation is that fits this data. And there are fitting tools. We're going to get more into that in a later chapter. But let's go here. And the fitting tools are not there. Let's go where in the we want to, oh, of course they're here. They're what's called trend line. Excuse me. It doesn't say fitting. It's called trend line. You even see a dotted line in the graph area. You click on the little right arrow there, and you can choose different things, and you'll notice exponential is the one to fit. And you can go to more options also. So more options gives you an exponential. You can display the equation on the chart, which is right down here. I'll make it nice and fat and big. Again, you can move this box wherever you want to. There we go. And change the font size on the box. There. So this is the equation. When you put the y-axis on a logarithmic scale and the data appears to be a straight line, this is the equation that it describes. It's an exponential equation. It's an exponential fit. Design. I wanted to go to trend lines, or I can right click on the trend line. By the way, you probably don't want to add another trend line because it just keeps adding trend lines. You want to right click on the existing trend line and go format if you want to change it. Exponential fit. And you've got other options too. Avoid polynomial unless the science tells you it's a polynomial. That's x squared, x cubed, x to the fourth, and so forth. You don't want to do that unless the science tells you that's what it is. Because you can go to any order of polynomial you want and it fits very well. The trouble is it can fit an elephant. It can fit any kind of data you want. The same thing's true of a moving average. That's used in marketing. It's used in things like stock analysis. It predicts, well, where's the price of this stock heading? Okay. We're going to get more into that later. So this is the briefest introduction into this topic. The next thing we're going to see is what's called the rocket equation. And we see a graph that looks a lot like this. It looks a lot like the previous one, like the capacitor discharge. Let's see what trend line would tend to work the best on this particular graph. So I'm going to add a chart element, trend line. I'm going to go more trend line options. Now we're going to look at linear. It's not linear, obviously. it doesn't let me do exponential. And that's a bit curious, probably because you never go to zero. The mass is on the x-axis. The mass of the rocket's on the x-axis, the velocity on the y-axis, by the way. That's what they represent. And again, I'm just omitting the axis titles because logarithmic, ooh, that looks darn good, doesn't it? Let's, okay, here's linear. Logarithmic, it just fits right over it. So that would mean we want to format the axis. Right click on the axis, format the axis. Let's put it on a log scale. So this time, this is semi-log x, straight line. And we don't even need the trend line unless we want the equations, which is not a bad thing. Logarithmic scale. There we go. And the equations right down here, just like before. I'm going to do one more before I end this video. This is a graph of radius on the x-axis, volume of a sphere on the y-axis. And let's try to add the chart element. Let's add the trend line. Come on, wake up, Excel. There, that's the numbers. When you see the bar chart, that's the numbers. It doesn't let me check out exponential. If I try I can try logarithmic. There we go. It can't use negative values. Okay, so let's go get rid of that. You know what? Exponential can't either. So let's do that. And right click on the trend line and format it. Now this is a linear plot. I don't know why it's curved because I selected logarithmic already. We've seen exponential, not a great fit. We've seen linear, not a great fit. We've seen, here's logarithmic, not a great fit either. Polynomial might be a great fit. Power, let's try that one. That's the one. Now, of course, a polynomial is a power. The power is 3 in this case. It would be a polynomial, a cubic, order 3 polynomial also. That's why you have to be careful with polynomials. You got to go to the science when you're dealing with the polynomials. So here's the equation for that. Y equals x to some power. The previous one, the rocket equation, and I didn't expand that. Let's go take a look at that. That's y equals a constant times the logarithm of x. And the previous one before that, y equals a constant times the exponential of a constant times x. Exponential. Rocket equation. This would be, now it's not showing the type it is. It'd be a logarithmic model with this format. Logarithmic scale on the x-axis. And this is power. It's a power model. And the logarithmic scale, we should put the logarithmic scale on both axes for a power model. Make it a logarithmic scale here, and make it a log. So log on the y alone doesn't work. Logarithmic scale, so x and y works. Now if I select the y-axis, if I take the logarithm off, doesn't work. So x and y are both logarithmic scales in this case. You see it goes from 1 to 10, And if it went further, it'd go from 10 to 100 and so forth. 1 to 10 is the same distance as 10 to the 100. That's how a logarithmic scale works. And with that, I'm going to end this video and we'll go on to the next video.